Today's video is going to cover lesson 2.8. This is evaluating functions, expressions, building off of what we did in the previous lesson where we evaluated functions that came out to a single value. This time they're going to come out as an expression. So the goal today is to use a function rule to evaluate a function when the input includes a variable, and that's why this evaluating functions is expressions, because we've got a variable that we're inputting into the function, so we'll have a variable when we get the output from the function. So a couple key terms today before we begin. We've got evaluate, which we know how to evaluate, but the formal definition of evaluate is to find the output for a given input. So if you're evaluating something, all you're doing is using the input that it gives you to find the output that matches with that input. And then variable expression, and this is what we're going to get when we evaluate today, is an expression that includes a variable, numbers, and operations. So we might see something like x plus 3, or we might see we've got variable, we've got number, we've got an operation, or we might just see 4x. So we'll see something with a variable, possibly a number, and definitely some operations. So here we have example number 1, and this first example, I'm showing you on the left what we did in the previous lesson, where we just evaluated a number, and on the right we've got today's lesson where we're evaluating given an input with a variable. So if it was asking us to evaluate using the function rule, and it gives us this function rule right here where f of x equals x minus 5. In the previous lesson what we did was we took our input, which is negative 2, and we put our input in for our x variable. So we took negative 2 and we said f of negative 2 equals negative 2 minus 5. So we put our input in for the input variable, and then we simplified it to get our output. So we've got f of 2, or f of negative 2, sorry, equals negative 7, where f of negative 2 is our output, which equals negative 7, and our input was negative 2. So we could say that our input was negative 2, and our output we can say is negative 7. Now, same idea, except now we've got a variable. So the outcome isn't going to be a single value like it was in this example. So when we put in f of negative 2x plus 1, so we've got f of, I should do this in white, f of negative 2x plus 1 equals, and we're going to put in our input, which is negative 2x plus 1, in for all the x's that we see. So we've got only one x here, so we're going to put in negative 2x plus 1 for the 1x, close the parentheses, and 5. And when you put in expressions, rule of thumb is to use parentheses because you might have some distribution you may have to do in some examples. So now we're just going to simplify this. So we've got negative 2x plus 1 in parentheses. They're not like terms. We can't simplify anything in the parentheses, so we can go ahead and drop the parentheses. So we've got negative 2x plus 1 minus 5. Now we've got two numbers right here, positive 1 and negative 5, that we can combine or simplify. We can simplify those to a negative 4, so we've got negative 2x minus 4. And these aren't like terms, so this is in its simplest possible form. So we can say that f of negative 2x plus 1 equals negative 2x minus 4. So our input in this example was negative 2x plus 1, and our output in this example was negative 2x minus 4. Next example. Here is example number 2, and it's saying evaluate f of negative x using the rule. So here's our function rule, and just like the previous example, we're going to take our input, in this case negative x, and input it in for all of the x variables in our function rule. So we can say that f of negative x equals 4, and we're putting in a negative x for this x, so we've got negative x minus 2. So when we simplify this, we've got 4 times negative x minus 2, so multiplication before subtraction. 4 times negative x, that's just a negative 4x, because we've got a negative 1 here, so negative 1 times 4 is negative 4, times x is just negative 4x minus 2. Nothing that we can further simplify, so we know that f of negative x equals negative 4x minus 2, where the input is negative x, and the output for that input is negative 4x minus 2. Example number 3. Evaluate the function rule 3 plus x using, evaluate f of 3 plus x using the rule. The rule is f of x equals 2x plus 1. So for those who like steps, these are two-step problems. The first step being to input or plug in the input for all x variables, and the second step being just to simplify. So the first step is we're going to put in this 3 plus x for all the x's that we see. In this one there's only one, so we can say that f of 3 plus x equals 2. Now I'm putting in 3 plus x for this x right here plus 1. Now we can go ahead and simplify. Multiplication comes before addition in order of operations, so we can go ahead and multiply, specifically distribute this. So we've got f, and I'm not going to write the f yet. This equals 2 times 3 is 6, 2 times x is 2x, and we can drop the parentheses and bring down the 1. Now we've got an x term, no other x terms, but we've got two numbers that we can simplify to one number. So we've got a positive 6 and a positive 1. Those simplify to a 7 plus 2x. These are not like terms, so we can say that f of 3 plus x equals 7 plus 2. And if we wanted to rewrite this with our variable first, we could say that this 7 plus 2x is the same thing as 2x plus 7. So I can put in the answer either way, the number or the constant first, or with the variable term first. Our input is 3 plus x, and our output is 2x plus 7. Two more examples. This is example number 4. So we're going to evaluate x plus 3 using the rule. The function rule is f of x equals negative 3x minus 1. And we're going to put in x plus 3 every time we see an x. So we've got x plus 3 equals negative 3. And we put in our x plus 3 and for the x minus 1. Now we can go ahead and simplify. Let's go ahead and distribute. We get negative 3x minus 9 minus 1. And we can go ahead and simplify these two numbers to one number. Negative 9 minus 1 is a negative 10. And that is the furthest we can simplify it down. So we can say that f of x plus 3 equals negative 3x minus 10, where this is the input and this is the output. Last example. Evaluate f of negative 2x using the rule. Here's the function rule. So we can go ahead and write f of negative 2x equals 3, and now we're putting in negative 2x or the x that we see, plus 5. What if this was a 5x? What would we do? Well, let's make it a 5x. Let's say that this is 5x. So we'd put in negative 2x for the second x as well. So I'm changing this function rule to show you that if there is more than one x, then you put your input in for every single x that you see. So here we have two x's, and we can say that f of negative 2x equals, and we can simplify both of these. We've got 3 times negative 2x is a negative 6x. And we've got 5 times a negative 2x is a negative 10x. These are both like terms, so we can go ahead and further simplify it. We've got f of negative 2x equals negative 6 minus 10 is a negative 16x, where negative 2x is our input and negative 16x is our output.